Hi everyone. So for my project, I made a classifier for handwritten digits using stochastic gradient descent. The overall idea for my project was to show that with today's libraries and packages, um, image classification can actually be easy. Anyone can do it. It doesn't have to be terribly difficult. Um, yeah, so in the spirit of that, the first part of my project, I essentially just used off-the-shelf functions. I didn't do anything special. I just took what was given to me in the package. I'm going to be using sciKit learn. I just took those functions and tried to see how good of a classifier I could come up with. And then later on, I tried to see if I could improve that or not. So just going through here, this is what our images look like. So these are all supposed to be handwritten zeros, and we can see that they are labeled as 0. Excellent. And then we go through and we get to the training and testing. Um, this graph here is just showing that we have an about equal distribution of the different classes in both our training and testing sets. So around 10% for both. Um, so excellent. And then we already know how stochastic gradient descent works, so I'll skip over that. So right here is where we actually fit the data, right? So we create our classifier, we fit our data, and then uh, we use our fitted classifier to predict labels. Okay, great. So we predicted some labels, but how well did it work? So we look at these confusion matrices to tell that. This one on the left here is showing the percentages of things that we got right. So this diagonal is all the things that we were correct about. It's not too obvious as to how well we really did. Um, this one on the right, though, we've zeroed out this diagonal, which makes our errors more apparent. And we see right here, really obvious, we are classifying threes as twos about 20% of the time. Overall, though, we get an F-score of about 0.892, which is pretty pretty all right for doing nothing special at all and just using out-of-the-box functions. It's not great though. So how can we improve this? Well, one thing we didn't do at all was pre-process our images, which is generally pretty important for, an image classifier. So one thing we can do is do what's called a hog transformation. A hog transformation, um, well, hog stands for histogram of gradient objects. Essentially what it does is it takes groups of pixels, like squares of pixels from the original image, and turns all those pixel values into just one value. So if we took a 3 by 3 grid, instead of 9 values, we just have one, which greatly reduces the amount of features we have to train on. So we go ahead and this is what it looks like. So these are all originally zeros, and you can tell that they actually do look like zeros. However, now there's a lot less information encoded in the image, which means we have less work to do for our classifier. So we go ahead and we run all the functions that we already did again. And we get some more confusion matrices and a different F-score. This F-score is 0.968, and we can tell that our percentages are a lot higher for scoring things correctly, all around almost 100%, so like 95 or so. And then in our zeroed out diagonal confusion matrix, we can see that we have still two main points of error, confusing twos as threes and sevens as zeros. However, these are only about 5% error, as opposed to the original 20. So overall, I just wanted to show that image classification doesn't have to be this terribly difficult thing, and you can get something up and running in maybe just a couple hours work. Thank you.